Dear students, today we will start a new concept in the pure mathematics, differentiability. You are very much familiar about the differentiability in class 11th and 12th, and you know how can you differentiate of the function by first principle, and you have find out the differentiation of the several functions, and you have also solved the problems on successive differentiation. It means a higher order derivations of the given function. But in at this stage, we will understand what is differentiable, how did it is discovered, what is basic concept of the differentiability, what is notation, and how can we solve the problems, and how the theorems uh, can understand, which are very useful in many problems of the different areas. First of all, we should know the real valued function. In previous classes, we are familiar about the functions. Now, real valued functions. A function whose domain is subset of the set of real numbers is known as a real valued function. Domain of the function should be subset of the R, the set of real numbers. So this is the exact definition of the real valued function. Derivative of function, a real valued function is said to be differentiable at x equal to c. It means at any real number. If limit of f of x minus f of c upon x minus c h x tends to c is finite and exist or unique, you can say. And symbolically we write d by dx f of x at x equal to c, or d of f of x at x equal to c. Many other notations may be possible here. Now we define two kinds of derivatives. Left hand derivative, shortly we write LHD. If limit of f of x minus f of c upon x minus c h x tends to c minus, yes, c minus 0 exists, how can we evaluate it? Put x equal to c minus h. As x tends to c, then h tends to 0. So replacing x by c minus h here. So f of c minus h minus f of c upon minus h. H limit x h tends to 0. Similarly, we can define right hand limit of the function. Limit of f of x minus f of c upon x minus c h x tends to c plus 0 exists, finite and unique. How can we say? Putting x equal to c plus h. As x tends to c, then s tends to 0. Put down these value in above. So we find that limit of f of c plus h minus f of c upon h as s tends to 0 exists finite and unique. Now, finally, we can say a function means a real-valued function fx is said to be differentiable or derivable if left-hand derivative of the function at x equal to c equal to right-hand derivative of the function at s equal to c should be exist. Then now we define differentiability in open interval AB. Since open interval AB means set of all real numbers lying between A and B, certainly they are infinity. A real valued function is said to be differentiable in open interval AB if it is a differentiable at every point of this interval. How can we define differentiability in closed interval AB? A function fx is said to be differentiable in closed interval AB if first one fx should be differentiable in open interval AB. Second, right hand derivative at x equal to a and left hand derivative at x equal to b. It means we say function is left hand differentiable. If all three conditions are satisfied, then you can say a function is said to be differentiable in closed interval AB. Now, to understand clearly, we solve some questions here. Check the continuity and differentiability of the following function. Function can be defined f of x equal to x square minus 1. X is greater than or equal to 1. And function will be equal to 1 minus x if x is less than 1. Check the differentiability and continuity at x equal to 1. First we check the continuity at x equal to 1. Put down x equal to 1, then we find f of 1. This will be equal to 1 square minus 1, that is 0. F of 1 minus left hand limit, we will take function less than 1. So limit of 1 minus x as x tends to 1 minus, here left hand limit. Put x equal to 1 minus h, put down this value and find and calculate it, we get 0 here. Similarly, we can find limit, right hand limit at 1. So f of 1 plus limit of x square minus 1 as x tends to 1. Put down x equal to 1 plus h and solve down, put h tends to 0, then we find here 0 also. So function is continuous beyond left hand limit of the function at 1, right hand limit of the function at 1 and value of the function at x equal to 1. All three are same. So we can conclude or we can claim that function is continuous at x equal to 1. Now we find the left derivative at 1. Similarly, we write f dash of 1 minus, 1 minus 0. Limit of f of x minus f of 1 upon x minus 1 as x is to 1 minus 0. Now f of x, use the function less than 1. So 1 minus x. Write down the proper function and calculate. You will find here minus 1. And a right hand limit will be obtained by 2. So left hand derivative at x equal to 1 is not equal to right hand derivative of the function at x equal to. So we can say that function is not differentiable.